Hello friends, welcome back to my new video, electrostatic video number 8. In this video, topics to be covered. First topic is continuous charge contribution. So, what is the continuous charge contribution? In a practical life, we don't have individual charge in nature. We have charge on a body in continuous form. See how there are three types of continuous charge contribution. First is linear charge density. So see linear charge density. Suppose there is a straight wire, infinity long straight wire. It has positively charged. So we have to find linear charge density, that is lambda, which is equal to charge on unit length. Charge on unit length, that is the linear charge density. So how can you find the charge? Charge equal to lambda times of L. Second type is surface charge density. Suppose there is a infinity thin surface that is positively charged, either negatively charged can be. I have positively charged sheet. So how can you find? Take a unit area, and that is sigma equal to charge on area. Charge per unit area is called surface charge density. So we have Q equal to sigma times of A, that is the surface charge density. See third types is volume charge density. Let's take a cubical body which is positively charged. Consider a unit volume and volume charge density, that is rho, equal to charge per unit volume, that is the volume charge density. So how can you find the charge? Q equal to rho times of V. These three types are continuous charge density. First linear charge density, second surface charge density, third volume charge density. And here is the formula of all three types. Now move in second topic. Second topic is electric field. It is very important topics of this chapter. Electric field. Suppose there is a source charge Q. So electric field, it is a region or space around this charge. This is called electric field, where another charge can experience a force. It is a region or space around a charge where another charged experience a force. Now let's find the electric field intensity. Electric field intensity. It is represented by E. So in electric field, let's take a point P. At P, another charge experience of force. So force experienced by a unit positive charge placed in electric field. So it can be written E equal to force experienced by Q, and suppose that is the source charge, and at distance R there is another test positive charge which magnitude equal to 1 coulomb. So force experienced by this charge at this point is called electric field intensity of that charge. Let's move another topic. Another topic is electric field due to a point charge. Electric field due to a point charge. Suppose there is a source charge at distance R, there is another point charge, that is plus charge. So what is the electric field? It is represented by Q. We know that is F upon Q0. So put the value of force. We know that is K times of Q0 upon R square. So that is E equal to, so Q naught can be cancelled. So we have K times of Q upon R square. So E equal to 1 upon 4 pi epsilon naught equal to Q upon R square. That is the formula of electric field due to a point charge. So if we draw a graph, there is 1 upon 4 pi epsilon naught and Q all are constant. So P is directly proportional to 1 upon R square. If we draw the graph between E and R, suppose take a E and that is R, so we have these types of curve. Now let's move another topic, that is electric field, electric dipole and dipole moment. Dipole moment. Electric dipole. What is the electric dipole? It is a system of two equal and opposite charges placed at very small distance see in the picture form, that is minus q, and at 2l distance there is a plus q charge. This system is known as dipole, electric dipole. Let's see what is the electric dipole moment. Electric dipole moment. It is a strength of electric dipole. It is strength of electric dipole, which is and it is vector quantity and its direction is always from minus q to plus q. See the formula. Formula is P equal to either charge and 2l distance, that is 2ql. It is the vector quantity and it is a product of either charge and distance between two charges, which is product of q and 2l. Now move another topic. Now friends, next topic, electric field lines and its properties and their properties. Let's see what is the electric field lines. Electric field lines is an imaginary lines or curve drawn through free space in which a tangent drawn shows direction of electric field or tangented by curve on which at any point a tangent drawn shows direction of electric field. It means how to show electric field lines. It is a imaginary lines which show the electric force or electric field. So suppose there is a plus Q charge, so how can you represent their field? We can represent field lines like that. It shows field lines is out from the positive charge. Suppose there is a negative charge, so all field lines enter into the negative charge. This is the electric field lines. Suppose there are two charges, one is plus Q and another is minus Q. So field lines is out from the positive charge and enter into negative charge. And between this free space, if we take a point P and draw a tangent on this point, so this tangent shows the direction of electric field, that is the electric field lines. So what is the properties of these field lines? First of all field lines is out from the positive charge, and all field lines enter into the negative charge always. They do not form a closed loop, never form a closed loop, because it's out from the positive charge enter into negative charge. It is a originated, it is a terminated. So, and this is the continuous lines, and between them there is no cut or no gap. These lines is continuous. And two field lines never cross each other. Suppose take another field lines, these lines never cross these lines, because if two field lines cross to each other, so we can draw on these points two tangents, and two tangents show the direction of two direction. This is not possible, because electric field is a vector quantity, it has only one direction. Electric field lines is dense near to the charges and rare away from the charges. These are the some properties which are asked in an exam. So this is homework for you. You study and write in your copy. Now move in next topic. Next topic is electric field line due to a dipole. Due to dipole, we know that dipole is the system of two equal and opposite charges which are placed at very small distance, that is 2L. This is the electric dipole. Electric dipole system. And what is the electric dipole moment? Electric dipole moment, that is P equal to 2qL. So electric field lines, electric field of dipole on axial position. See, due to these two charges, we can find the two electric field. One on axial position. What is the axial position? Line joining of these 2 points take a charge on these lines are distant from the midpoint. This is the axial position. So find the electric field on this. Suppose this is the midpoint, this value is L and this is also L and this distance is L. So electric field due to minus Q, that is K times of minus Q upon what is the distance, what is the distance between this and this point. This is R plus L whole square. So what is the electric field due to plus Q? That is K times of plus Q upon what is the distance between BP, that is R minus L whole square. So what is the net electric field? That is, see, first, due to this charge, the direction of electric field is electric field lines goes toward the negative side. So electric field is this way, minus Q. And what is the electric field direction of electric field lines due to the plus Q? That is E plus Q on this side. So these two field lines are opposite sides, so they can be minus. So from which value to which value be minus? So see here, this is R plus L and this is R minus L. So this value is less, so this value is more than this value. So you have to minus plus Q minus Q. So put the value of here Q times 1 upon R minus L whole square minus 1 upon R plus L whole square. So solve it. That is K times of Q, R square plus L square plus 2 RL minus R square minus L square minus 2 plus RL and R square L square whole square. So this value will cancel. We have only E net equal to K times of Q 4 RL upon R square minus L square whole square. So we know that P equal to 2QL. Put the value of here. E net equal to K times of 2Q R 2Q L into 2R upon R square minus L square whole square. So E net equal to 1 upon 4 pi epsilon naught P R upon R square minus L square whole square. This is the net electric field on P point. So if R is more L, then E net equal to 1 upon 4 pi epsilon naught P, that is R for 4 and R will be cancelled, though E net equal to 1 upon 4 pi epsilon naught equal to P upon R cube. That is the final expression of electric field of dipole on axial position. Now see the electric field on the equatorial position, another position. Now friends, electric field of dipole on equatorial position. What is the equatorial position? Suppose there is a dipole and the distance between dipole is 2L. From midpoint take a point P at distance R. So we have to find out the electric field on point P due to minus Q and plus Q. So let's see. Join these 2 points AP. What is the direction of electric field due to this minus Q? We know that all electric field lines come toward the minus Q, so direction of electric field is this, that is E minus Q. What is the direction of electric field due to plus Q? Join these lines, and we know that electric field lines is away generated from plus Q, so the direction of electric field is this way, that is plus Q. Okay, so write the values of these two field lines, that is minus Q equal to K times of minus Q upon what is the value of AP? AP square, that is K times of Q upon what is the value of AP, that is this value is L, this value is R, so under root L square plus R square by Pythagoras theorem. So write it down there, R square plus L square whole square. Now electric field due to the plus Q, that is K times of plus Q upon BP whole square, that is K times of Q upon under root L square plus L square whole square. See how L and R, so under root R square plus L square, that is the distance between BP. So what is the net electric field, that is E net, which is equal to, now see the net electric field always between E plus Q and E minus Q, so this field can be this. So what is the angle between there? If angle between these two sides are theta, so this is also be theta and this is also be theta. So write the components of these electric field. It can be E sin theta and E cos theta. E cos theta, and here E plus Q sin theta. And similarly you can break these electric field into components. First is E minus Q cos theta, and this way E minus Q sin theta. As you see, the direction of these two field lines, they are equal and opposite, so they can be cancelled. Only these two field lines are in same direction, so they can be added. So net electric field is 2 times of E cos theta. These are the equals. minus q equal to E plus q. You can see these values are equal. So put in the value of here 2. What is the value of E? That is k times of q upon under root r square plus l square whole square. And what is the value of cos theta? You can find out the value of cos theta from this triangle, that is L upon under root r square plus a square. So solve it. 2k, put the value of k, that is 1 upon 4 pi epsilon naught q l 2ql, and under that is root can be removed due to square and this, so r square plus l square, that is 1 plus 1 upon 2. So put the value of, we know that p equal to 2ql, so put the value of here 1 upon 4 pi epsilon naught, that is p upon r square plus l square, that is 3 by 2. If r is more than l, then net electric field equal to 1 upon 4 pi epsilon naught p times of r cube. That is the final expression of this electric field of dipole of on equatorial position. Let's move another topic. Now friends, next topic is torque on a dipole in uniform electric field. Torque means turning effect of force. Suppose there is a uniform electric field, between these field lines place a dipole, that is AB, here minus q, here positive q. So what is the value of force? That is F equal to QE, and what is the value of their force is F equal to minus Q. These two forces, F due to minus Q and F plus Q, these two forces equal and opposite. They cancel each other. Cancel each other. So net force will be 0. But these two forces act on two different points and make dipole turn. So turning effect, that is tau equal to, we know that cross F, the formula of turning effect, tau equal to R cross F. So what is the, this is the distance between two forces, this is the perpendicular distance. So see here, what is the perpendicular distance? Perpendicular distance between forces, that is one force is this, one force is this. The distance of this, if this is the angle theta, so this is 2L sin theta, that is R equal to 2L sin theta. And what is the force? Force equal to either charge QE. So put it the value of there, you know that 2L sin theta into QE. So 2QL E sin theta, and we know that P equal to 2QL. So put the value of here P sin theta, that is the final expression of turning effect of two forces in uniform electric field. Now next topic is work done by the dipole in uniform electric field against torque. Work done against this torque. So see here, work done against torque on dipole. See, suppose there is a uniform electric field and there is a dipole which is angle theta from electric field, that is P minus Q, and that is plus Q, that is AB. If we F equal to QE and there F equal to QA, so we have to turn this toward this angle theta. So what is the work done? That is tau times of d theta. If we turn as small theta, so put d omega equal to tau times of d theta, and theta equal to 0 to theta. So put the value of here, that is P sin theta d theta 0 to theta. So P is the constant, so sin theta d theta equal to 0 to theta. So P is, that is cos theta minus cos theta, that is 0 to theta. Put in the value of here, Pe sin theta minus cos theta minus 0, that is 1. Minus minus we minus 0, that is 1. So final expression is, that is 1 minus cos theta, that is the total work done on turning effect of dipole in uniform electric field. Now we have covered all these topics. Okay, you have any problem, so you can write